Hello everybody, my name is Dr. KCH Apparao, working as an associate professor in mechanical engineering department. Okay, in previous classes we discussed the question bank questions, different critical analytical questions and some numericals also. Okay, in this class I want to discuss about the problems which are based upon the LMTD method. LMTD for counter flow and LMTD for the parallel flow. Okay, so we'll see first numerical. We know that formula according to LMTD, that is Q is equal to UA into delta T LM. Okay, so delta T LM is nothing but logarithmic mean temperature difference. So that is delta T1 minus delta T1 by ln of delta T1 by delta T2. We know this formula. Okay. According to LMTD. So delta T1 is different from the parallel to counter. For parallel flow, inlet temperature THA minus TCA, inlet temperatures. This one is the TH0 minus TC0. So these are the delta T1 and delta T2 values for the parallel fluid exchanger. But in case of counter flow, delta T1 is nothing but hot fluid inlet minus cold fluid outlet. So similarly, delta T2 is equal to hot fluid outlet minus cold fluid inlet. So these are the formulas, we know that. So based upon these delta T1 and delta T2 values and the formula which is Q is equal to rate of heat transfer Q is equal to UA delta TLM. We will solve some numericals based upon the either parallel flow or counter flow. Okay. So here one numerical has been given. We will see, we discuss this one. So first we will note what is the data given in this numerical. So first one, saturated steam. Saturated steam means here hot fluid inlet and outlet is equal to 0. Okay, that is 100 degrees Celsius. You know this. So saturation means so inlet outlet temperatures are equal. So saturated steam at 100 degrees Celsius is condensing on the cell side of cell and tube heat exchanger. The cooling water enters the tube at 30 degrees Celsius. Okay. So TCA is equal to 30 degrees Celsius and leaves TC0 is equal to 70 degrees Celsius. Okay. So calculate the mean temperature difference if the arrangement of parallel flow. Okay. So we have to find out the delta TLM. Okay. So for this is the parallel flow heat exchanger. Parallel flow heat exchanger. So here we can observe this temperature graph. So hot fluid inlet and hot fluid outlet temperature is equal to same, is equal to 100 degrees Celsius. Because this is a saturation position, means inlet and outlet both are same, that is the steam. So THI and TH0 is equal to 100 degrees Celsius. Okay. Cold fluid inlet TCA, you know that value. TC0, that is the value is equal to 70 degrees Celsius. Okay. Then you have to find out the first delta T1 and delta T2. For parallel flow, delta T1 is equal to, so in parallel flow, both the inlet temperatures at one side, outlet temperatures and other side. Hot fluid inlet minus cold fluid inlet. So that is equal to hot fluid inlet means 100 minus cold fluid 30, that is 70 degrees Celsius. Similarly, delta T2, hot fluid outlet minus cold fluid outlet. 100 minus cold fluid outlet is 70 degrees Celsius. So equal to 30 degree Celsius. Okay. So you know that delta T1 and delta T2, then you can find out the delta TLM here already given. So LMTD delta TLM is equal to, so delta T1 minus delta T2 by ln delta T2 by delta T1 by delta T2. Okay. So we know that delta T1, that is the 70 minus delta T2 30 degrees ln of 70 by 30. Okay. So 40 by ln of 7 by 3. Okay. So you know this value, that value is equal to 1082.702. So this is the value. Okay, in this case you can find out, by using this one you can find out the overall heat transfer. So rate of heat transfer, for this one you should know overall heat transfer coefficient and the area also, then delta TLR. If you know this one, you can find out Q also. So next numerical will say water flows at a rate of 65 kg per minute, convert into kg per second first. So mass flow rate of water has been given. So mass flow rate of water, that is 65 kg per minute, nothing but 65 by 60. So that one is the kg per second. So mass flow rate of water, MC, because water is the cold fluid, through a double pipe counterflow. So the heat exchanger, type of heat exchanger is counterflow heat exchanger. Water is heated from 50 degrees Celsius to 75 degrees Celsius. It means TCI is equal to 50, TC0 is equal to 75 degrees Celsius by an oil. So oil is the hot fluid, okay, flowing through the tube. The specific heat of the oil is, CH has been given 1.78 kilojoule per kg Kelvin. So 10 cube joule per kg Kelvin. You know this. Okay. Oil temperature is also given. Oil enters at 115 degrees Celsius and leaves to 70 degrees Celsius. Oil enters, THI is equal to 115 degrees. TH0 is equal to 70 degrees Celsius. Okay. Then overall heat transfer coefficient also given. U is equal to 340 watt per meter square Kelvin. This is the value. So these are the given values. Then you have to find out the heat exchanger area and the rate of heat transfer. So area you have to find out. Q also you have to find out. Okay. Now we'll see to find out the first of all Q. Once again, just we can observe the what is the data given in this numerical. So inlet temperature, cold fluid inlet temperature, that is the water inlet temperature 50 degrees Celsius. Outlet temperature 75 degrees. Specific heat of hot fluid specific heat. So CPH. Okay. So 1.78 kilojoule per kg Kelvin. Just convert into joule per kg Kelvin. Hot fluid enters 115 degrees Celsius. Hot fluid outlet 70 degrees Celsius. And overall heat transfer coefficient 340. So this is the given data. Okay. Then you have to find out heat exchanger area A and the rate of heat transfer Q. You have to find out. So first of all, you find out the Q value. Q is equal to MCCC into T cold fluid, TC0 minus TCI, one formula, is equal to same Q is equal to MHCH into THI minus TH0. So these are the formulas. Okay. So here MC, mass flow rate of water has been given. So that is nothing but 1.08. Okay. So 1.08 mass flow rate. Specific heat of the water, we know that 4186. So joule per kg Kelvin. This is the standard value. We have to remember this one. 4186. Then temperature TC0 is equal to 75. TCA is equal to 50. Okay. So if you substitute these values in this formula, we will get the specific heat. Rate of heat transfer Q. So Q is equal to 113 into 10 cube. It means 113 kilowatts. This is the Q value. Now we will find out the area of heat exchanger. Area of heat exchanger. Because you know that formula, rate of heat transfer formula, we already got the value of heat transfer coefficient, rate of heat transfer value. So you know that formula according to LMTD, UA into delta TLM. It means UA into delta TLM is nothing but delta T1 minus delta T2 by ln of delta T1 by delta T2. Okay. So you know that value of Q, and you know that overall heat transfer coefficient also. Then you have delta T1, because this is the counter flow. According to counter flow, delta T1 is equal to hot fluid inlet minus cool fluid outlet. Similarly, delta T2 is equal to hot fluid outlet minus cold fluid inlet. So all the temperatures have been given. Then you can substitute those values in this formula. Then you will get the delta T1 and delta T2. Here you can observe here. Okay. So this is the formula. Then you can substitute this delta T1. Delta T1 is equal to hot fluid inlet minus cold fluid outlet. Okay. Delta T2 is equal to, for counter flow, H0 minus TCA. Hot fluid inlet 115 minus cold fluid outlet. Cold fluid outlet. So cold fluid out 75. 115 minus 75. Okay. So this is the value. It means 25, 30. Okay. 40. So this is the value. Similarly, H0 value is given 70 minus TCA. TCA is equal to 50. So this value is equal to 20. Okay. So if you substitute here in this formula, what is the formula? Delta T1 minus delta T2 by ln delta T2 by delta T1 by, you can take like this one also. Delta T1 minus delta T2 by ln of delta T1 by delta T2. That are the formula. Okay. If you substitute these values here, and you know that value of Q. So Q value is equal to that 113 into 10 cube. So this is the value. This is the 113 into 10 cube. And overall heat transfer coefficient is the 340. So this value is equal to 340. And this value is, you know, this one, 40 minus 20 by ln of 40 by 20. 40 by 20. If you substitute all the values, then you will get the area. Area is equal to, you can see, area is equal to 11.54 meters square. So in this way, you can solve the numericals which are based upon the LMTD. We'll see one more numerical. Water at the rate of 68 kg per minute. Okay, mass flow rate of water has been given, and is heated from 35 degrees to 75 degrees Celsius. Okay, by an oil having specific So very similar to the previous question. Okay. Uh, so specific heat of the oil also CPH value 1.9 kilojoule joule for kg Kelvin, okay, kg degree Celsius also. You can take anything. The fluids are used in a counterflow double pivot. So here also this arrangement is equal to counterflow heat exchanger. The oil enters the exchanger, that is 110 degrees Celsius, and leaves to 75 degrees Celsius. Overall heat transfer coefficient is 320. Calculate heat exchanger is similar numerical. We know that the total heat transfer is determined from the energy absorbed by the water. Okay, energy equations, we know this one. Q is equal to mc cc into t c naught minus t c. Okay. So mc, mass flow rate of the water, 68 by 60 into cc 4180. So specific heat of the water, you know this one, into t c naught 75 minus 30. Okay. If you solve this one, you will get the Q value, that is nothing but 189.5 kilowatts. Okay. By using this Q, you can find out the area. So for this one, you know that formula, that is delta T Lm is equal to delta T1 minus delta T2 by Ln delta T1 by delta T2. According to for counterflow, delta T1 is equal to hot fluid inlet minus cool fluid outlet. Delta T2 is equal to hot fluid outlet minus cold fluid inlet. So these are the temperatures have been given. Then you can substitute those values in this formula. Then we'll get the delta T1 and delta T2. THI 110 no 75. So this is the 110 no minus TC naught, that is 75. So both the 75. So here TH naught is the value 75 minus TC naught is 35. Okay. So this is 30. This one is equal to 35. Then you can substitute these values here. You will get the delta TLM value. So that the delta TLM value is equal to 37.44. Okay. If you know this value, then you can find out the area. For the area, so Q, you know that Q is equal to UA into delta T Lm. U already given. Otherwise, we require area here. Area is equal to Q upon U into delta T Lm. Q is equal to, so what is the value? Q is equal to 189.5 into 10 cube by overall heat transfer quotient, that is 320 into delta TLM is equal to 37.44. Okay. So if you solve this one, you will get the area value. So one more numerical we will see, then we will conclude this one. In a counterflow double pipe heat exchanger, this one also counterflow heat exchanger, water is heated from 25 degrees Celsius to 65. Water means TCI is equal to 25 and TC naught is equal to 65 degrees Celsius. Okay, by an oil with specific heat and specific heat of the oil TPH is equal to 1.45 into 10 cube joule per kg Kelvin. Mass flow rate of the oil also given, that is the mH is equal to 0.9 kg per second. Okay. So next, water is cooled from hot fluid inlet 230 degrees Celsius, hot fluid outlet 160 degrees Celsius. Overall heat transfer coefficient U also given, that is the 420 watt per meter square degree Celsius. You know all the values, you can find out the So you have to find out here rate of heat transfer Q, you have to find out mass flow rate of water MC, you have to find out surface area A, you have to find out. Okay. First you have to find out the Q value. You know the formulas for the Q value. So this is the given data. You can note this one. So first Q is equal to, there are two formulas out there. One MC, MH and CH, mass flow rate of hot fluid, specific heat of the hot fluid. Both are given. Then we can take this formula MHCH into THI minus TH0, hot fluid inlet minus hot fluid outlet. So all these values as given. Then by using this formula, you can find out the Q value here. So if you know that Q value, then you can find out the MC also, because Q is equal to MCCC into TC0 minus TCA. This is the formula. CC 4180. Okay. So TC0 value, you know that one. So that is 65 minus 25. So by equaling this one, you can find out the MC like this one. Okay. So equal this one, because Q is equal to same formulas. So MHCH is equal into hot fluid to temperature difference is equal to MCCC into cold fluid temperature difference. Then by using this one, then all the values you know that one. Then by using this equation, you can find out to MC. MC is equal to this one. So you know MH 0.9, CH specific heat of oil 1.45, hot fluid entering 230 minus hot fluid leaving 160. CC specific heat of the water, okay, 4180, because this is in kilojoules, this one also just kilojoules happened, that was written in kilojoules, okay, into TC0, TC0 65, TCA is equal to 25. Then you will get this value, mass of the water, okay, mass flow rate of water MC is equal to 0.545 kg per second. So then if you know this one, you know all the values from which you can find out the Q values. Q MHCH into hot fluid temperature difference. MH, you know this one, 0.9 into 10 Q into 1.45 into 230 minus 160. Okay. So we will get Q value. Q is equal to 91.235 kilojoule per kg Kelvin. Okay. So then you can find out the area. We have to find out the area. So for this one, you know the formula. Q is equal to UA into delta TLM. So delta TLM you have to find out. So this one is the counter fluid exchanger. Delta TLM is nothing but delta T1 minus delta T2 by ln of delta T1 by delta T2. Okay. So delta T1 means for counter flow hot fluid inlet minus cold fluid outlet. Delta T2 hot fluid outlet minus cold fluid inlet. Okay. So if you substitute all the values, you will get to delta TLM value. Okay. So then here you know that Q value, you know that U value, oral heat transfer coefficient. Then you know that delta TLM value. Then you can find out the area. So the area is equal to 1.45 meter square. So in this way, just you can solve the numericals. So this one is the one more numerical. You can solve this one. Just I am leaving this one. So these are the different test books for the reference I have given here. You can refer these test books. Okay. Thank you listening this class.
Like, share and subscribe. Hit the bell icon for more updates.